Hi everyone, welcome to World of Fusion 360. This is a part 2 of generative design for seed bracket. In this video, we are going to see how to explore the results. After your study is complete, it will show green check mark here. It will probably take 1 to 2 hours for a study to be done. When it is done, just click on explore generative results. It will switch to Generative Design Explorer view. Here you can see all the generated outcomes and various options to filter down and choose the results that you need. So let's see what we are having in the canvas. So if you hover over your mouse, you see the model that is generated and a check mark. Here you can see the filter icon. It indicates that the feature is preview feature. It means that they are not yet fully finalized. It's like beta stage in the Fusion 360. So for now, it indicates die casting and experimental solver. Here we have blue bar, which indicates the iterations that were done to bring the design to the final stage and converge. Here we have study 1, structural, and outcome 2, the title of the outcome. Here converged. So converged in the sense all the setup that we have defined in the generative design workspace are converged or met. And here we are having outcome filters. By using these filters, we narrow down our selection path. And here we have display, in which we can view the results and various other forms so that it helps in further filtering. Let's see what we have under outcome filters. Here we have recommendation settings. If you click on these, these are the parameters that you can adjust so that the Fusion 360 recommends you the outputs. Here we have 4 outputs, right? Those are based on these recommendation settings. If you alter those, the recommendation settings will change. So if you choose low manufacturing complexity, it is giving you the outputs based on that. If you choose high, it is giving you based on that. So you can vary these parameters to get the recommended outcomes and narrow down or select your outcome even faster. Under processing status, we have converged and completed. Converged are the outcomes that have met the design criteria that we set, and completed are the ones that are close to that objective but did not meet that criteria. At any point of time, you can isolate any of these and inspect whether the outcome meets your requirement or not. So these are the completed ones that did not meet the criteria that we have set already. Now I'm gonna isolate only converged. So total we are having 127 outcomes, and in that 122 are converged outcomes. I'm gonna collapse recommended outcomes, and here it filtered all the 122 outcomes out of 127. Generative models and study. So if you're having multiple generative models, it will show here. And similarly for the study, so since we have defined any other studies, it is showing only one. Visual similarity. Based on visual similarity of the design, it will group them in the categories. So if you click on isolate of any group, it will show you that particular shape or visually similar designs in that group. So if you can see, group 2 is having similar kind of shape. Subsequently other groups. I'm gonna reset those and collapse. And here we have design file. Here tech preview. Technology preview is the thing that I told you, right? So this filter icon indicates that sometimes die casting can be done, and for some other outcomes, it says that the new experimental solver has been used to generate this outcome. So this filter may indicate that it can be manufactured by using die casting, or else the outcome was generated by using the new experimental solver. Fusion 360 recently introduced new experimental solver in which the designs were better in this one. I'm gonna reset that. Here we have manufacturing method, materials, objective, ranges. If you expand manufacturing method, you have unrestricted additive 3-axis, 5-axis milling, die casting. These are the methods that we set in the design setup, right? So unrestricted are the outcomes that do not consider any manufacturing criteria. I'm gonna omit that and I'm gonna isolate additive, and now under display switch to properties view. What it will do is, under the designs, it will show all the properties of that particular outcome. You see here it is having status, converged, generative model, material, orientation, in which the nozzle direction is, visual similarity as we have seen earlier, production volume that we set in the setup, piece part cost and fully burdened cost are the things that incur when you go for mass manufacturing. So this is the cost for piece, and this is cost for including all the additional expenses that are going to occur when you gonna produce in mass. Here we have volume, mass 0.134 kg, and one more is stress, factor of safety limit, minimum factor of safety, maximum displacement. So if you observe the cost, it is like $61 for a piece part as a median, and for 3-axis it is 16, 5-axis it is 24. I'm saying that on an average or roughly. Die casting, this one. So when you see for additive, it is like way higher. I'm gonna omit this option also. So I'm gonna select 3-axis, 5-axis, die casting. Now my filter for manufacturing method is applied for 3-axis, 5-axis and die casting only. These are all the outcomes that belongs to that particular manufacturing method. Coming to materials, these are the materials that we have defined in the setup, right? So at any point of time you can isolate any of the material and you can pick the material outcome that you want. Here we have objective ranges, so you can set the minimum and maximum range so that the outcomes will be filtered within that range. So I'm gonna set minimum factor of safety to close to 2, and the piece part cost to the maximum limit to 100. So it filtered all the outcomes based on that criteria. I'm gonna switch to thumbnail view so that I can view the results. I'm gonna click on this outcome and see what it has inside, and I would like to inspect this outcome fully. So here on the right we have study 1, structural, component outcome number 62, and all the properties are listed here. And here we have our design popped up. Underneath that you see iteration bar. So it took 22 iterations to get this design finally. So it started with the iteration 1 with maximum material, and it converged, it removed material, and it calculated all the criteria that we have set, like the factor of safety and the material and manufacturing method, whether this iteration meets or not. It further converged and brought this design for us. So generally what happens is you'll design and you make the modifications, and it won't meet the manufacturing criteria, and you modify it again. The same has been performed here, and it brought this final outcome which matches all these criteria. In the display we have model view. You can inspect the model easily here, and transparent view helps you to inspect whether there is any cavities in the design. Stress view allows you to check the most prone areas that are stressed. So the areas which are in red are prone to high stress, so you need to pay attention there. So since there are no areas that are red, it is good. So this is a design preview. This is how your model gonna look like when you export it. Here we have preserves and obstacles. You can enable these to have better visualization, and you can compare this result with other if you click on this one, and you can add it to favorites so that you are interested in this design. You may want to check back later any point of time, or you can add a label. I'm gonna add a label as filtered best. So I'm gonna finish outcome view, and in here you can see in the labels filtered best is here, and you can click on isolate to show only that. And then we have scatter plot view. I'm gonna click on this, and you see currently it has on y-axis it is having mass, on x-axis it is having minimum factor of safety. You can change it to anything, maximum displacement, piece part cost, whatever you want. So I'm gonna keep it minimum factor of safety and mass on y-axis. So here you see these 4 outcomes are having more than 3.5 factor of safety, and the weight is also considerably very less. So this outcome is having the factor of safety 2, and also the weight is very less. You can click and drag to zoom those particular outcomes. If you select on any one outcome, it will display the properties and the thumbnail of that particular outcome. Here we have open option and iteration option. So if you click on this, it will show you the iteration trend. If you reset the zoom, you can see the iteration trend clearly. So it started from here and it went in this direction and came all the way to converge here. I'm gonna close that, or you press the control and select any outcome to show the same design iterative trend. So in this option you need to hold the control and left mouse button continuously. If you leave it, it will go back. So let's see what are these outcomes. So outcome number 58 and 57, 60, 61. So these are the outcomes that I'm interested in. I'm gonna go to thumbnail view and select 61, 60, 57, 58. If you click here, it will bring all those 4 to this view so that you can compare the results better. So it brought all those models to this workspace, and if you click on any outcome, the properties are displayed on the right. I'm gonna switch to model view so that I can better visualize the geometry. And if you zoom by selecting this navigation button here, you can see the areas that are prone to degraded geometry here. So we can select this outcome, but what happens is you need to work on it again to correct this geometry. It will take additional time to process these. So I'm gonna omit these two outcomes. So now I'm left with outcome number 60 and 61. I'm gonna see the properties and compare them. So for outcome number 60, the factor of safety limit is 4.72, and for outcome number 61, the factor of safety is 4.858. So I'm gonna omit all the other things such as weight and factor of safety. I'm gonna focus only on maximum displacement. So for this outcome number 60, it is having 0.304 maximum displacement, and for this 61 it is having 0.296, which is slightly less, but this is the thing that I'm going to consider for filtering it further. I'm gonna select outcome number 61. I'm gonna close it. So we need to export this outcome as our design. So to do that, I'm gonna select design from outcome here. One more option is mesh design from outcome. So I recommend you to go for a design from outcome, because you can convert this design to mesh at any point of time after you export it as a design. I'm going to click on that. I have already exported it as a design. So if you click on that, it will open a dialog box and it will ask for your confirmation. If you say okay, it will take 10 to 20 minutes to process that outcome. After it processes, you will get this option, design ready. Click to continue. If you click on this, you can open your design by clicking here. So now it opened our exported design. So here we have preserves, obstacles, and our generative design. You can check these things by dragging the timeline. Here we are having our preserves and obstacles. If you expand bodies, we have 4 bodies, and now our generative design. It used a boundary fill to fill the material and then combined to cut the extra material. Now it bought our final design. I want to check this design and also make changes in the design. So here we have a cut. So it is due to the geometry that we have defined. I'm going to select that face, and similarly here I'm going to select that, say delete. Now it got deleted. I'm going to save it so that I won't lose it. I'm going to switch to simulation. I'm going to validate this design. So it is asking that the generative design setup is already there. You want to invoke that? Yes, I want to invoke that. So now you no need to set up anything in the simulation workspace like you will be usually doing. It already set up everything for you, the load case, backload, everything. If you want to make changes, you can go back and you can make changes here itself. And simply I'm gonna click on solve once steady. So it is sending all the data to the cloud, and when it is done, it will receive the results and it will show us. But before that, I'm going to switch to design workspace, and I want to make changes like by removing this hole, and I would like to see the result. I'm gonna double click on this form. So I'm going to remove this hole and fill it. So I'm gonna select any phase in between this hole, and hold shift and double click on adjacent phase to select all the other phases. Say delete. Now double click on this edge to select all the edges, and right click, say fill hole. It will patch it up. I'm I'm gonna say okay. Again, repeat fill hole. Select that edge by double clicking on it, or else you do the same. Double click on it and repeat fill hole. Either way the same. So now that we have filled that hole, I'm gonna say finish. I'm gonna switch to simulation. So it is saying that the results will be out of date. I'm gonna clone the steady. In that way my previous results won't be impacted with this modification. Now I'm gonna solve it again. When the simulation is done, you'll get the results like this. So to get into results workspace, just click simulation results and it will show the results here. So with the fine mesh we got a 1.284 and the minimum factor of safety that we set is 2. But this is the criteria of a small region. So if you slide the bar, it will show the areas that were prone to this 1.284 stress. So if you expand it, so you can see from 3 the major area is lying. So underneath 3, so there are only small areas that are prone to this kind of stress. So that won't be a much problem with our design. So this is all for today. Thank you so much for watching, and this is part 2 of exploring results and exporting the outcome.
Thank you so much for watching this video. Hit that like button if it helps you, and subscribe to World of Vision 360 for getting notifications each time when we upload new video like this. Thank you so much guys. Have a good day. Bye bye.